Hello, this is Ms. DB, and in this lesson we're going to learn about volume of prisms and cylinders, and we'll learn how to use the formula for each of those. Volume is the space inside of a three-dimensional figure. It is, the way our book describes it, is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. It's how much cubic units are inside of a three-dimensional figure. There's a Cavalier's principle that says it doesn't matter for volume if you have a right three-dimensional figure, you know, straight up and down like this triangular prism is, or if your prism is oblique or your cylinder is oblique, has been like tilted over. The reason for that is that if they have the same height and the same cross-section, like both of these have the same exact triangle as a cross-section, then they'll have the same volume. So if they have the same base, which is the same shape as this cross-section, and the same height, they will have the same volume. Here's the formulas that you're going to need. Volume of a prism with base area, B, big B, and height, H, is volume equals area of the base times the height. Remember that a capital B is not just one number, it's something that you have to solve for first. You have to find the area of the base by whatever means you've learned in chapter 9 for finding area of a polygon or a circle, and then you multiply it by the height. So this is something that you have to solve for, this big B. If it is a box, a rectangular prism, you can use the formula that volume is equal to length times width times height, because see, that is the area of the base, length times width. That's why this works, is because this is big B. And the same thing for a square. In this one, the base is a square, which would be side squared, and you'll multiply it by the height, which is also S in this picture, so you could just take one side, which they're all the same, and cube it for the volume of a cube. Here it says to find the volume of the prism. It is a rectangular prism, so you can use the formula area of the base times height. The area of the base would be 13 times 3 because it's a rectangle, and then we multiply that by the height. So it doesn't matter if you take 13 times 3 and get 39 and then multiply that by 5, or if you just multiply on your calculator 13 times 3 times 5. Now if you use the little special formula for a rectangular prism, that's what you'll get the same thing. 13 for the length, width would be 3, and the height would be 5. Either way, you're going to get the same answer of 195 centimeters cubed. For volume, we use a little 3 for our exponent on our unit because this is cubic units. In this one, they don't have a picture, but it's easy enough to draw a picture of a cube. A cube, remember, has the same length, the same width, and the same height. And they say that each of these are 15. So you could do area of the base, which would be a square, which would be 15 times 15, and then you can multiply that by 15 for the height, or you can just go 15 cubed and get 3,375. Now here's an interesting one. In this one, our base is a hexagon. Now remember that to find the area of a hexagon, we have to think about that hexagon as being divided into 6 triangles. And each one of those triangles would then be divided again to get a right triangle. So this would be 60 degrees, 360 divided by 6. And then we would divide that by 2 to get a 30 degree, this is 30 up here. My triangle isn't very accurate, but this is the right triangle. So to find the apothem, let's see, we know this would be 4.5. We will need to use tangent. So we'll have to go that the tangent, oh, they don't even show you how they found that. To find A, you would use the tangent of 30 degrees is equal to the opposite side of 4.5 over the adjacent side of A. And then we would multiply both sides by A to get A out of the denominator. And then we would divide by tangent of 30 to solve for A. Tangent 30. So we have that A is equal to 4.5 divided by the tangent of 30. And then we need to use, you might remember 30, 60, 90 is a special triangle. So you might remember tangent. Let me draw a 30-degree triangle here. In a 30-degree triangle, this is my 30. I'm not drawing these very accurately. The short leg, which would be this one, is half of the hypotenuse, and the other side is square root of 3. The long leg is square root of 3. So the tangent of 30, this doesn't include the 4.5. The tangent of 30 is 1 over the square root of 3, or the square root of 3 times the square root of 3. You rationalize the denominator to get the square root of 3 over 3. That's the tangent of 30. So we're taking, this is a little more advanced algebra here, we're taking 4.5 divided by the square root of 3 over 3. So one way to simplify this would be to multiply top and bottom by 3, which cancels this 3. And we would have 3 times 4.5 divided by the square root of 3. 3 times 4.5. 15, that's 12, 13, 13.5. So 13.5 divided by the square root of 3. So the apothem is equal to 13.5 divided by the square root of 3. It might be time to get a calculator to figure that out. Where's my calculator? Okay, 13.5 divided by the square root of 3 is equal to, oops, I think I hit, well, maybe that's right, 7.79. Or, on our calculator, what if we had just done 4.5 divided by tangent of 30? There's my tangent. 7.79. So either way, we get 7.79. So our apothem we got is 7.79. Oh, they're still finding the apothem there. They got a different apothem than I did. They have 4. Oh no, that's the same thing, I bet. I'll leave it here. Yep, 7.79. Okay. They rationalized their denominators, what they did. Go back. All right, now we have to find the area of this hexagon. So if our apothem is 7.79, and we have this right triangle that's 4.5, so here's our right triangle. It's 4.5 here, 7.79 here. Or we could find the area of this triangle, which would be 9 by 7.79, and there's 6 of them. There's a formula for area perimeter or polygon, which is 1/2 the perimeter, because you take all of these together, times the apothem. So we'd have 1/2 times 9 times 6 is 54, times our apothem, which is 7.79. So they ended up, let's see, we would get Yeah, it's the same numbers. This is the 7.79 right here as a decimal. So 1/2 times the apothem times the perimeter is equal to 121.5 times the square root of 3, which is approximately, I wish I had a calculator that would just come up when I wanted it. 121.5 times the square root of 3. $210.4444. 210.4444. That's just the area of the base. And then the formula for area volume is to take the area of that base, which is 210.444, times the height. So take the area of the base, which is what we found, and multiply it by 12 to get approximately 2,525.3. Hey, they didn't cube it, they squared it. It's supposed to be cubed here. It's volume, so there's a mistake there. All right, so that's how you find one of those more complex ones. All right, this one says to find the volume of a triangular prism with a height of 9 yards whose base is a right triangle with legs 7 and 5. So your formula for volume is area of a base times a height. Now, why didn't they write that? They wrote that here is your area of a base. So volume is equal to area of the base times the height. And they're like, well, we know how to find the area of a right triangle. You would take 1/2 base times height. But they didn't want to use b again because they thought you might mix up what a little b and a big B is. So instead they called this the length and this the width. But it's the same thing. You would take 1/2 5 times 7. That's the area of the base. And then, of course, this is a triangular prism. That's just the bottom part. It has a height of 9, so we would multiply that by 9. And this is what you would get. So this is how Cavalier's principle would look if you stacked a bunch of CDs up. You can see that they would have the same volume. If you just kind of tapped on this one so that it would make this tilted shape without tipping over, this shows Cavalier's principles. They both have the same number of CDs. They have the same volume. And the formula for cylinder, either a right circular cylinder or a oblique one, is area of the base, which is a circle, times the height. So for a cylinder, you can always use this formula, pi r squared h, because that's big B right there. So remember that if they're giving you the diameter, you need to find the radius by 1/2 of that. So this would be 9. And then you would take pi times the radius squared. 9 squared is 81. So pi times 81 times the height, which is 14. Now this one says to leave your answers in terms of pi and rounded to the nearest tenth. So you'll have 2 answers. One answer would be, what does this end up being? 1,134 pi. And then if you actually use your pi button on your calculator and multiply these two, you get about 3,562.6 inches cubed. Remember to label these with the unit that they gave you and put the little cube, the little 3 by it for the exponent. All right, find the volume of a cylinder with diameter of 16. Diameter of 16. As soon as I see diameter, I'm like, well, I don't want diameter. I want radius. So here's my sloppy little cylinder here. They gave me a diameter of 16, but I need a radius of 8, and a height is 17. So the formula is pi r squared h. You plug in 8 for r and 17 for h. You simplify to get 1,088 pi, and then you multiply to get 3,418.1 inches cubed. This is the same thing. Oh no, this one's different. This is example 4. All right, now it says what happens to volume if you change the dimensions. So in this one, we're changing both of our height and our radius, all of our dimensions, multiplied by 2/3. What do you think will happen to the volume? We haven't done a volume one before because we're just learning about it now. So here's the volume of our original. Now if I change them by 2/3, I'm actually going to be making them smaller. This new cylinder will be a smaller cylinder. Stupid thing. Here we go. So here's my smaller cylinder. 2/3 of 24 would be, that would go in there, 8 times would be 16. So now I have 16 for a radius, and my height would be, sorry about that. My height would be, let's see, I have 33 times 2/3. So that's 11. 11 times 2 is 22. And then I would take and fill that into the formula. So here's my two volumes that I get. How does one compare to the other? The best way to do that is to write them as a ratio and then simplify that. Which would be 5632 pi over 19,008 pi, and the pi's cancel. And if you get a fraction calculator, you can simplify these, and you'll find that they simplify to 8/27. Well, 2/3 to the third power is equal to, well, that's equal to 2 cubed over 3 cubed, so it's equal to 8/27. So what you do for volume is you cube the factor that you changed your dimensions by. So in this one, the length, width, and height are doubled. They're doubled. So you would just take 2 cubed to find that the volume will increase by 8 times. So you can actually find your original volume, and then you can multiply each dimension by 2 and find the new volume, and you'll see that 18 times 8 equals 144. All right, here's a composite figure. To find the volume of a composite figure, you just find the volume of each piece and then add them together. So we have the volume of a rectangular prism on the bottom, which is just 8 times 4 times 5, 160. And then we have a triangular prism. And let's see, this is 8 here as well. So for the triangular prism, this part would be the base. It's actually facing this way, but that's our base. To find this, right now we don't know the height of our triangle, and we need to know it. So we would take, let's see, this would be 4 and this would be 4. It's a right triangle, so we can use Pythagorean theorem. So we can say 4 squared plus h squared equals 8 squared. That would be 16 plus h squared equals 64. And subtract 16 from both sides. So we get h squared equals 48. And then you take the square root of both sides to get that h is approximately, well, they found that h is 4 square root of 3. And left it like that. And then we would take the area of the base as 1/2. This triangle up here would be 1/2 times 8 times 4 times the square root of 3. To simplify this one, you would take, this is the same as 16 times the square root of 3, so that's 4 square root of 3. So now to find the volume of the regular triangular prism, you would take the area of the base times the height, which is actually this piece, because remember this is the base, and the height connects the two bases together. So times 5. So altogether you would get 64 times the square root of 3. 16 times 4. Hey, they used, oh, I'm sorry, it's 4, it's not 5. This piece right here is equal to this piece, which is 4. I saw that wrong. So 64 times the square root of 3. Then finally, we would add together this number. Let me get a different color. This green. Add that together plus this together. And if you want to round then by finding the square root of 3, we would get approximately 270.9 cubic centimeters cubed. And that's the volume of the whole thing. So to find the volume of a composite figure, you find the volume of both pieces and add them together. All right, thank you very much. Have a wonderful day, and let me know if you have any questions.